My father was a scientist, and his father, my grandfather, was a scientist as well. I remember when I was very young reading my grandfather's subscription to Chemical and Engineering News. I was very fortunate in high school to have excellent teachers, especially in chemistry and physics. And then when I was very young, I read books written by and about very famous scientists that live very interesting lives. Now, my inspiration comes from the people that I work with, my students, my postdocs, very energetic. I'm very lucky to work with, very, very creative people come to me with amazing ideas. And I think we feed off each other's ideas. A long-standing interest of my lab is bacterial cell-cell communication. So all of it is focused on understanding how bacteria function and how we can disrupt those functions. We've known for over 100 years that bacteria take up DNA from the environment and incorporate that DNA into their own genome to acquire new traits. And my lab has been very focused on determining at the atomic level, using techniques called X-ray crystallography and cryo-electron microscopy, how these protein nanomachines, if you will, bind to the DNA, pull it to the cell, pull it into the cytoplasm of the bacteria, and then recombine that imported DNA with their genomic DNA. Bacteria have a very elaborate machinery for taking that DNA into the cell. So we used to think that bacteria lived in isolation, that they were, free living and didn't interact with their neighbors. We now know that that's far from the truth. Our ultimate goal, though, is to develop antibiotics so we can treat people and prevent disease.